Welcome back to Solving Systems of Equations by Elimination. Today we're going to go ahead and revisit this topic. The main idea is you are adding two equations together to eliminate one of the variables so you can solve for the other one that's left. So if they're exactly the same but opposite signs, like in number 1, you would add to eliminate those. If they're exactly the same but not opposite signs, like in number 2, you would subtract to eliminate the x. I'm going to go ahead and go through the more difficult kind where it was the subtraction. So if we take a look at number 2, we notice that we want to subtract one whole equation from the other whole equation. So the x's are going to disappear, be eliminated. Now 4 take away 7 gives us negative 3y. 24 take away another 24 is 0, so negative 3y equals 0. Then we can divide by negative 3. And remember, 0 divided by anything is 0, so y equals 0. And that's half of our answer. The next part is to plug it into either equation and solve for the other variable. So I'm going to choose the top equation. So 8x plus 4y, but instead of y, I'm going to actually put in timesing the value I just found, 0, equals 24. Now, at this point, it's just simplify and solve. So 4 times 0 is 0. So I just have 8x equals 24. Divide by 8 on both sides. And we get x equals 3. So our ordered pair here would be 3, 0. All right. The next thing that we want to notice is sometimes you have to multiply one equation by a constant to get the same coefficient. And you can also multiply it by a negative if you need to get opposite signs. Let's take a look at number 3 this time. These, notice the equations 4 and 7, they're not super close together, but 6 and 12 are. And they happen to be opposite signs as well, which is super helpful. So the first thing that we're going to do is we're going to decide how is it that I can make one the other. And I decided that I can make 6 y's into 12 y's if I multiply the whole thing by a new factor 2. So I have negative 14x plus 12y equals negative 2. Now the top equation I didn't need to change, so I'm just going to bring that down here. So negative 4x minus 12y equals minus 16. And now I can add these equations together to eliminate the, not the x's, the y's. So the y's turn into 0. I'm left with negative 18x equals negative 18. And now it's a one step, so I'll divide both sides by negative 18. And I get my value of x equals positive 1. From here, I plug it into the other equation, to either equation, to see what I get. And I'll try the top one just to see how it goes. So negative 4 times positive 1 minus 12y equals minus 16. So negative 4 minus 12y equals negative 16. That is a two-step equation. So eliminate the constant to isolate the variable term by adding 4 to both sides. And you get negative 12 times y equals negative 12. And then turn the coefficient into a 1 by dividing by the coefficient. And that gives us y equals 1 as well. So our ordered pair is 1, 1. And that's when you have to multiply one equation by one constant. Now, the other thing that you might have to do is you might have to rearrange an equation before you multiply it. So let's take a look at number 6. This one, we need to rearrange so that they all look the same. Now, what I did on this one was I'm going to rearrange it so that I have them all lined up in columns. So I'm just going to draw a little arrow and I'm rearranging things. So the first one, I can leave it by itself. I have negative 3y plus 9x minus 15 equals 0. Now, if that minus 15 equals 0 bothers you, we can rewrite it by moving that 15 over to the other side. And in addition, so if we add 15, then that's going to become equals to 15. And that's a lot easier for some students to understand. Now, the next equation, I want the y's in my first term, so I need to move it to the other side. So I'll have to subtract 1/8 of a y. So this will become negative 1/8 y. The x is already there, so I'm going to put plus x. And then I don't have anything on the other side, so it will equal 0, because when I subtracted the 1/8 y, I'm left with 0 as my constant. Now, let's identify what we can make the same. And if I'm looking at these, basically I want to make, how about the x's the same? And if I'm going to do that, I'll go ahead and multiply that negative 1/8 y plus x equals 0 by a 9. And I'll go ahead and show you how to do not only by 9, but if I multiply it by negative 9, then that will allow me to simply add. So I have positive 9/8 of an x minus 9, wow, I said that one wrong, minus 9/8 of a y minus 9x equals 0, because 0 times anything is itself. I'll just bring the other equation down as we can see them right next to each other. And now notice that I have the exact same coefficient on the y's with opposite signs, so we're going to go ahead and add those two equations together. The x's are eliminated, and I'm left with, let's see, 9/8 minus 3, or 9/8 plus negative 3 is going to give us negative 15/8 of a y. And then we have that equals to 15. Now, usually I divide by the coefficient, but I'm going to remember that I can times by its reciprocal in this case to turn it into a coefficient of 1. So timesing by 8 over 15, and the negative always floats to the numerator. So I'm going to also times this one by negative 8 over 15 and realize that 15 is over 1. So on this side, these all cross cancel to give me 1y. And on the other side, I have some cross-canceling happening as well. So notice that the 15s cancel each other out, and I get negative 8 as my value for y. Now, once I know that part, I can find x really easy by using this. So x equals 1/8 times negative 8. And so my answer here would obviously, as these cross-cancel, give me a negative 1. So your ordered pair is going to go ahead and be negative 1, negative 8. Always put the x and then the y value. So that's when you have to rearrange and times one equation by one constant. Now, the last thing I wanted to review is if we have to times two equations by two constants to get common coefficients, and also rearranging the equations. So we're going to go ahead and go on to the back page, and we're going to look at number 11 here. Now, on this one, we do need to rearrange it, so let's go ahead and do that first. Now, this one might be easier if we think about it as maybe slope-intercept form, or something of that effect. How about we do the negative 3/4 x. Let's put the x in the first term, and then let's move the y over. So I'm going to have plus y, and I'm going to leave the constant on the other side, 1/2. And then the bottom equation is going to be similar. Let's move the x over first, so it's negative 5x and plus 7y, and I'll leave the 2 where it is. So those are my two equations. Now the different terms are lined up one on top of the other, we can go ahead and see what we have to multiply to make these common. Now, if for some reason you don't want to deal with fractions, we can always look and see, well, what can make these into a common coefficient? And I'm thinking a common coefficient could be 15. If I multiply this one by 20, and I can multiply this one by 3. And then I get the equations of, let's see, the 20, the 4 divides in, so this would be negative 15x, and then plus 20y equals 10. And on the other equation, I have negative 15x plus 21y equals 6. All right, now notice I have the exact same coefficient with the exact same sign. Had I wanted to, I could have made one of these negative so I could add, but we've done a lot of adding, so I wanted to throw in a subtract. So I'm going to take the top equation and subtract the bottom equation. So from here, the x's are eliminated. The y's become negative 1y, and 10 minus 6 would be 4. So if 4 is the opposite of y, when I divide it by negative 1 on both sides, then I get y equals negative 4. From that point, I have to just plug it in to solve for an x. So I'll go ahead and choose, how about the bottom equation, since there's no fractions. I know a lot of you don't love that. So 0 equals 2 minus 7 times the value we just found of negative 4 plus 5 times x. So negative 7 times 4 is going to give us negative 28. And then I have 2 minus 20, plus 28, since the negatives are going to cancel each other out. Plus 5x, and that still equals 0. From here, combine the constants. That gives you 30. Plus 5x is 0. Move the constant over by subtracting it. So negative 30 equals 5 times x. And that will give us our value of, when we divide by 5 on both sides, x equals negative 6. So our ordered pair here would be negative 6, comma, negative 4 in parentheses. Please remember to always put parentheses around your ordered pairs, or they are not ordered pairs. And that we have a coordinate. All right, that is where we'll leave you. Go ahead and get started on your assignment for the reteaching of equations by elimination.